Hello. This time we're going to discuss the chain rule and implicit differentiation. So the chain rule indicates that for a pair of composable functions, composable indifferentiable functions f and g, right, the derivative of the composition of f with g is given by this particular rule. So, for example, if we said let y be given by x squared plus x plus 1 cubed, we identify y as the composition of two functions. The first one being f of x equal to x cubed, and the second one, g of x, being x squared plus x plus 1. Of course, from this decomposition, it's not so difficult to see that the derivative of f relative to x is 3x squared, while the derivative of g relative to x is, well, 2x plus 1. Okay, so by the chain rule, we have y prime is equal to f of g of x, right, prime, which now it's given by f prime at g of x times g prime of x. But then you may say, well, but what is this? This is f prime evaluated at x squared plus x plus 1 times g prime of x. I'm going to make the evaluation step by step. And this one would be f prime evaluated at x squared plus x plus 1 times 2x plus 1. And finally, well, now it's just a matter of substitution, because this says that if I consider this as a function, it takes its input, squares it, and multiplies it by 3. So that would be 3 times the input squared, right, times 2x plus 1. So here, what this says is that the main idea is that while applying the chain rule, we need to identify a non-trivial composition for the function of interest, right? Just as we did here. So here, an application, a problem, right? A problem involving all of this. Okay, first let's find an equation of the tangent line to x squared plus y squared equal to 1. So this curve is a circle of radius 1, center at the origin, at the point given by square root of 3 divided by 2, comma, 1/2. So, first thing, note that indeed, if I make the replacement, this results in 3 divided by 4 plus 1 divided by 4, which is 1. So the point is on the curve. But what is the problem with this, right? The problem is that a circle, right, just as the one that we're describing here, is not a function, right? It's not the graph of a function. But we can pretend it is. And for that, we have a theorem that can help us, that this is C, the implicit function theorem. That indicates that under certain conditions, when you have a description, like an equational description, like in this case, right? We may pretend that locally we do have a function, right? But then let's see. Even with this at hand, right? How do we find what we need? Meaning an equation for the tangent line. Well, first, let's see what we can do. We pretend, or we suppose, that y is really a function of x. So we apply the derivative as an operator on the equation. How so? Well, just as the one that I'm going to describe here, I will have d dx operated on x squared plus y squared should be the same as if I operate it on 1, right? This is like applying a function on both sides. We lose nothing here. But wait. From here, we obtain the following information. I have that I can decompose this as the derivative with respect to x of x squared plus the derivative with respect to x of y squared. That would be equal to 0. Now, this is not complicated. This is 2x. But this one, well, that really is an application of the chain rule, because I'm thinking of this y, right, as really y of x squared. So, what is supposed to be this? Well, this has to be, according to the chain rule, 2 times y, the function, times y prime, the derivative, and all of this being equal to 0. Well, and then from here, it's just a matter of algebra, because now I have that 2y times y prime is equal to negative 2x, which is the same as to say that y prime is equal to negative 2x over 2y, but that is the same as to say that this is negative x over y. So, at the point square root of 3 divided by 2, comma, 1 over 2, y prime is the following. It's just negative of x, which would be the first coordinate, the square root of 3 divided by 2, over 1 over 2, which reduces to negative a square root of 3 times 2 over 1 times 2, which now is just negative a square root of 3. There we go. So this is the slope of the tangent line. Well, we have a slope, we have a point, we can use the point slope formula. We get an equation for the line. What is that line? Y minus 1/2 is equal to negative square root of 3 times x minus the square root of 3 divided by 2. Of course, we can have an equivalent description as follows. It would be y is equal to negative square root of 3 times x plus 2. And, well, whichever description you prefer for an equation of the tangent line to this circle at this point. Well, I hope that you like it, and take care. Don't forget to subscribe and place your request. See you later.